Hello. Say hello. Good. Thank you. Students, my ex-colleagues at C-DAC, Ashish, Parikshit, Nitin, Swati, thank you very much for having me here. Welcome to all the new students. I have this presentation, which I wanted it to be as short and brief as possible, but it's probably not that easy to make it very small. Bear with me while I take you through this. Okay. All right. Here's the outline of this talk. There is part 0. Engineers start counting at 0, not at 1. There's part 1, and then there's part 2. Right? With me so far? Good. The first part is, in part 0, I'm going to ask you and all of us, why are we here? Right? What brings us here today? Right? And if you look carefully at this, I'm asking, there are really 2 questions here. First is why, and the second is me. So why am I here? Right? My reason for being here today, of course, the fact is C-DAC invited me, but I'm here primarily to deliver to you a message which has 2 parts. All right? Why me specifically, I will explain. Hopefully you will understand towards the end of part 1. And the second part of this whole talk is, why are you guys here? Right? Again, 2 parts to the question. Why and why you specifically? Right? Now, you might imagine that you're here to learn something, right? Perhaps VLSI or advanced computing or the Internet of Things, but really you're not. Okay, at least I don't think you are. Right? If you're not surprised by this point, you will be soon enough. Second question is, why specifically you? Right? And this hopefully should be clear by the end of part 2. All right? So part 1, I'm going to talk about the gap between academia and industry. All right? Academia and industry do things in the same thing perhaps, but in very, very different ways. All right? And we'll talk about this gap a little bit. So here are the fundamental differences between these 2 paradigms. Okay. The first one is, what is the primary focus, okay, of these 2? In academia, it's your marks, all right, and in industry, it's profit. Okay, we in industry don't do anything unless I can make money off it. There's really no point, right? It's not charity. It's not. I can't distribute product for free. It has to be a profitable enterprise. What are the goals of academia? It's primarily correctness in your exams, right? You are considered successful when you write correct answers in exams. However, in the industry, it is correctness in products. Okay. Now, there is a reason why these 2 are different. You might imagine that correctness in exams, correctness is correctness, right? What's the big difference? The difference is you get an attempt to do something in an examination. You get a certain marks, right? Some number, and that's that, right? Unless you fail, in which case you do it again. But in industry, you always have the opportunity to keep improving, keep going from correctness today to more and more correctness. Otherwise, you wouldn't have an iPhone 15 after a 14, right? Or a 15 after a 1. What about output quality, right? Output quality in academia is, there is a need for perfection, right? Whatever perfection is, might be defined as. But in the industry, good enough is good enough, right? What does good enough is good enough mean? It means you take it to a certain level that is acceptable by definition, and you stop at that. Because if you never stop and you keep refining, you'll never have a product in your hands. You'll blow your timelines. In academia, value is given to prestige, right? You are here because C-DAC is very, very prestigious. But in industry, the greatest value is given to how efficient you are while executing something, how smoothly you can do something, how few hitches you have, right? How not only quickly, but with least cost, right? You can develop a new product, or you can develop new software or something, whatever it is that you are doing. What is the time preference? The time preference in academia is often from the past to right now, right? We teach things that were discovered or invented perhaps centuries ago, calculus 500 years ago. But in the industry, it is forward-looking. I want to develop products that will be in the market 5 years from today, right? It's always looking towards the future because profit is in the future for my actions. What about ideas and novelty? Ideas, there is novelty in academia, but that leads primarily to new discoveries and the publication of papers. Whereas novelty, doing something new, inventing something in industry leads to patents. Okay. The speed in academia is usually slow, and perhaps sometimes it's medium fast, because again, you're teaching and you probably cannot go at breakneck speed with students. But in industry, it is fast to insane. Sometimes we do things at insane speeds. Communication in academia is usually one way, like what I'm doing right now, talking to you. But in industry, it is two way, right? I talk to you, but then I expect you to also give me ideas and feedback, and that is how jointly we develop products. The behavior in academia, okay, is competitive. Okay, professors, teachers compete with each other for papers, prestige, better quality grants, and so on. I mean, perhaps not in, I mean, I don't know in C-DAC, but elsewhere in the world, in universities, that is the paradigm. And in the industry, it is primarily collaborative. I need to collaborate with my peers. I need to collaborate with other partners in the industry. I need to collaborate even with universities in order for us to build something, right? And the goal, the focus is building new things. And you can't compete. I mean, you compete later when the product is built with your competitors. But till that time, you collaborate a lot. The work paradigm in academia is often silo mode. Silo mode meaning that there is a professor who has a research team, and they're researching a particular topic or something. And in industry, it is rarely like that, right? You're always cross-functional. I might be doing chip design for a group, but consulting with the software people and doing thermal design and doing chassis design for something. And it's always cross-functional. You're always talking to cross-functional people. There's a huge difference in that work paradigm. And resource usage. Right? In academia, oftentimes it is wasteful and misallocated, how we'll come to. But in industry, resource allocation has to be extremely efficient, because if it is not efficient, you lose money. And industry is all about money and profit. Okay, it's not a bad thing, by the way. The fact that it is about profit is what makes buildings like these possible, makes education like this possible, and so on. Okay, so what is this root cause fundamentally? Okay, why is it that the industry and academia have such a huge gap, right? The root cause is that fundamentally teaching methods are wrong, right? The science of teaching, which is pedagogy, has evolved over the years in such a way that the sequence of learning new things is in the same order, okay, as advances in knowledge. For instance, if you think about calculus, which arguably Newton invented some centuries ago, as an advanced course, it was taught in universities at that time, right? But subsequently, there have been new developments in mathematics, discrete math, various types of things, like topology, graph theory, right? This part of discrete math. So these things are, first of all, they have more application, okay? They are more relevant, but they are not taught, at least in the early stages. I mean, it's very easy to teach someone who's in class 8 or 9 set theory, right? Or perhaps a little more advanced group theory. But no, you will teach people calculus in class 10 or 11, and they probably might never ever apply it in their whole lives, right? So today, for instance, just to give you an example, advanced maths is not calculus. Calculus is a specialized discipline for some kinds of engineering applications or some kind of physics applications, right? But it's pointlessly, it's taught today, right? Now this thing, this method of this sequence, what you teach first, what you teach later, has never been examined carefully by universities. They have a certain syllabus that's been continued over the years. Nobody actually goes and tries to reform that, right? Or think that should I change the entire structure of teaching? A new institution, a private institution might be able to do it, but then they don't have prestige, right? The effect of this is very crippling. Okay, what happens is it slows down your speed of learning, right? If you missequence what comes first and what comes later, you get stuck in a loop. You don't understand this, but you have to go to an advanced concept. Then you don't understand the advanced concept, or you understand it partially, you go back to the first one, and you stay stuck in a loop, right? That loop wastes a lot of time. So this slows down the speed of learning. It teaches unnecessary things, right? So for instance, people who are in software engineering now may never use calculus their whole lives, right? But every single one of you has had to learn it. Now, there was no real need to. I could have given you perhaps an introductory course, a very short and intuitive understanding of what it really means, but you don't need to go into drill down deep into, prove this and prove that. Perhaps not, never going to use it ever in your life again. It bores most people, okay, and generates hatred for the subject. Most people start hating it, right? Why am I doing this? This is crazy. I don't want to do this, right? And then on top of that, you're made to compete, right? That, oh, my friend got 98% and I got 97%, right? It kills your curiosity. It also kills the desire to learn. Now, these are all interesting subjects. Yeah, I have nothing against calculus. It's a wonderful subject. But when you need calculus as something that you're going to apply, right? That is when it is interesting. Right? If you're never going to use it, it's not terribly interesting for you. Now, what it does is misallocates resources, right? If I take a human being as a resource, then and that person is fundamentally an artist, right? Steve Jobs was an artist primarily, right? His art field was calligraphy or and also typesetting, right? But that's why he had to drop out of college, because they were like, learn calculus or learn discrete math. He doesn't want to do that, and yet the man successfully started up. Right? So this whole error, right? If you imagine this as an error, what does this do? It creates a vicious cycle, right? The students who come out of academia to industry, when I interview them, okay, even when they have advanced degrees, even when they have done an MTech or a PhD, they are quite useless in the real world. I'm being candid here. Sorry if the word offends you, but really speaking, they're useless. I mean, I hire people. It takes me a year before a student, even who has done a master's, is productive in the industry. Okay, students have some theoretical knowledge, but I cannot take a fresh graduate and give them a project to execute independently. I cannot say, go build a chip for me. These are the specifications, or you figure out the specifications and you build a chip. I can't do that. Right? Or a big chunk of software, for instance. And this effect is so pronounced, okay, that we can't find good candidates, okay, and almost every new hire is a compromise to the industry, okay, to the point where, at least in a startup like ours, or in a fast-moving, cutting-edge industry, the rejection rate of candidates is like 90%, right? We reject 90% of the candidates we interview. Now that is shocking, right? We expect candidates to be ready after they come out of college, and they're not. Okay, we are under tremendous pressure to hire, right? Because we have to build products, right? And we have to also pay good money, because there is competition between companies, right? My competitor is paying you a package of, oh, so much and so much, right? And I can't pay that much, and things like that. So it creates a pressure to hire, to give good money to the candidates, but the candidates are not there in terms of what they are supposed to give back to the company, right? So this creates another effect that it creates is attrition. Okay, people who join freshers, they especially don't stay in the company for very long. Okay, because first we can't give them big responsibilities and the good work that they expect, right? We can't give them that because they aren't ready to do that. And because they don't get it, they feel unsatisfied and then they quit, right? So it creates this cycle where getting good talent and retaining that good talent has become very hard in the industry. Okay, now that is our loss, and it is also your loss, because since you don't come at that level of readiness, right? What ends up happening is you don't get the good work. You don't get enough of good work, sorry. And because of that, you don't get an opportunity to learn either, right? So your career growth stays slow, and industry also can't move fast enough. We also can't build our products quickly and with reliability and accuracy, right? So this is a nasty, nasty thing that has happened. Now, there are better ways, okay? Better ways do exist. Now, there are fundamentally, if I go back to academia, there is always a better way to teach any subject, all right? These ways, first of all, they reduce the amount of time significantly. Okay, I always tell people that if you want to learn, for instance, C, then I can probably end up teaching C to a basic novice in a few days, a month at most to master it. How long does it actually take? In academia, probably a year. And we still don't get people who master the language, right? The reason for that is the starting point, okay, of most people who are familiar with, for instance, C, is a printf statement, printf hello world. To me, that's extremely wrong. You should not start, that is the wrong starting point, in other words. You should start with pointers, which is memory, how to get into memory, change data, write data to memory, read data back from memory. These things, when you master, the rest of C is essentially just a byproduct. All right, it is merely putting in words the concepts that you already learn in terms of how memory works, how data works. Similarly, if for people who are in chip design or who have a familiarity with Verilog or VHDL, the way to teach it, two key concepts. One is synthesis, which means given a description in words, how do I figure out that this is a circuit? How can I draw a circuit from it? And the second is a concept called event queues, which is the key concept if you want to do simulation. If you master these two concepts, literally there is nothing else that is left in Verilog or VHDL that is that doesn't flow naturally from here, and that takes time to learn or time to understand. And this is not how things are taught in academia or even in courses. If you're going to learn maths, the right starting point is actually discrete maths, because everybody is familiar with numbers. If I tell you 1, 2, 3, 4, you understand that. If I give you vague concepts like a delta between two numbers, delta y upon delta x, where something tends to 0, it's hard. It requires a vivid imagination, right? It requires you to be able to imagine this thing. But there's no imagination required. 1, 2, 3, 4. It's easier to teach that. It's easier to learn that, right? And build upon that eventually. But the order is reversed in pedagogy. Photography is something I'm interested in. Whenever people teach photography, they immediately go into difficult concepts, composition perhaps, or color balance. None of these things really matter, because your camera, the light sensors, they always see 18% gray. They are calibrated to 18% gray. If you understood this concept, you would actually know what your camera or your digital sensor is going to do, which means if now it is no longer some kind of non-deterministic process, it becomes deterministic. I want this effect, this is exactly what I'll do to get that effect, right? But it's not taught that way. So, to teach a language like Sanskrit, perhaps, I chose Sanskrit as an example because it has a clean grammar, right? So if you learned the concept of rule-based languages, right? Learning Sanskrit is really, people think it takes years to master. It's not true. It hardly takes a few weeks at most, right? And you would be happily reading the Ramayana, the Mahabharata, the Vedas, whatever it is that you wanted to read, and you would be reading it and understanding it. In a few short weeks, you could do that if it were taught right, but it isn't, right? So the idea here is that of a key concept. If you master this key concept first, the rest of the subject simply flows naturally from that key concept. Okay, and it improves your learning. Now, why did I go into all of this? This is the backstory, or this is the background which caused the starting of this advanced computing training pool. This act, right, of certain and the academia, that is to and industry. Academia does speak. And what we described meeting up our standard in the past few slides. We wanted to create professionals who are turn off. All right. So we want people want industry ready. Okay, that is the key word at the end of this short 6 months. Our executive director was man. Already spoke about him a little bit. Building India's first super. Okay, acts Vivek Sawant. Another is this, and often have questions in the and discussion this fact, right? It was always a point of lament that we aren't getting good people, but then there's nobody to teach well also, and so there's a vicious there. So okay, that they recognize this gap to address, and from that was started. I was with developing the course, developing the syllabus, and also teaching that course, which I did. And as they say, the rest is history, and you are here. So this is the end of part 1, right? If you have questions, I'd be happy to take them at the end, right? And now we come to part 2. Okay, part 2. So we spoke about, or didn't speak about, it's one way right now, the gap between academia and industry. Okay? But there is also a gap between you as students and you in your future selves as professionals. Okay, now we'll talk about this. If anybody where this line comes, no Lord of the Rings fans here. One ring to rule, no. 2 qualities to bin them all. Binning means to separate, either create 2. My experience over the last 30 years, and there are 2 qualities for the last years. There are 2 primary qualities that I look for in any individual. And if this in them, I can immediately classify if these qualities do not exist, this is mediocre. Okay, I can separate mediocrity from excellence with just right. Okay, so can you distinguish the root cause of anything from the proximate cause? Right now, if you're not familiar with these concepts, the root cause is a deeper reason for something happening. Right. So I'm walking here, and I slipped and fell. You will ask, why did you slip and fall? Oh, there was water there. That is the proximate cause. That is the near cause, right? There was water, so I slipped and fell. Or there was a banana peel, so I slipped and fell. The bigger question to ask is, why was there water there? Right? Who dropped the water? Why wasn't the water mopped up? Why wasn't it clean? Right? And why wasn't a sign put there or something put there warning that this floor is wet? So there are additional failures that have happened for this final effect of me slipping and falling to have happened. Right? So when you dig deeper and deeper and deeper, you eventually arrive at a reason which is termed the root cause, the first primal cause because of which this chain of causality happened, for which demonstrates a final effect. Right? So the one of the things that I was saying is the ability to is one of the characteristics to distinguish that a particular cause is proximate and not root, and the ability to dig deeper and deeper through analysis to find the root cause. Right? The chain of causality, what caused what, and because of character independent thinking, anything at face value. Thinking is not accepting. Somebody says something, you shouldn't accept it unless you have the analysis in your mind thoroughly done. The ability to think free of constraints. Each of these creates bias in your mind, right? You think, oh, I should do a BE or a BE. Why? Lots of very successful people never did it. But we have a bias. A bias is merely so can you think yours, right? So that's of this depending. And you should not expect to be spoon fed or exact. It means you should be able to do all of this on your own. Nobody should have to tell you, go think for yourself, go figure this out. Okay, this should come in your own mind, on your own, that I need to do this. Right? That independence and independent thought is one of those very key characteristics that distinguish the exceptional from the mediocre. And the second one, okay, is multidisciplinary expertise. Right? When I say multidisciplinary, I don't mean that, oh, you can do chips and you can do or you can write software that software design is apps, image processing software, and also do some animation. No, actually, two or more that are absolutely different from each other. Two fields or fields that are not with each other. Okay, perhaps art, music on one end, and mathematics on the other, or even these two are actually connected. Not a good example. These are extremely diverse. Okay, history and languages, or natural anthropology, perhaps, and chip design. Right, people who have this diversity of knowledge and experience and hobbies, right? They want to do these different things, right? What ends up happening with those people is they gain the ability to apply insights and intuition from one field into another field. All right. So the observation that I have had is people who have this multidisciplinary expertise, okay, they are the ones who are truly exceptional. They are the ones who truly make a difference by inventing new things or discovering new things. They are the ones who create patents, write papers, make publications. So this is a very important distinguishing ability. The idea being you learn from one field and apply in another. Okay, I'm now going to talk about resources. Again, you might think that this presentation is slightly disconnected. These slides are disconnected with each other, but they'll all hopefully come together in the end. Resources is, what is resources? Okay, resources, anything really. Sitting in this hall right now is a resource. Okay, speaking here is a resource, right? Everything can be thought of as a resource, right? Like everything can be thought of as money. Time is a resource. Okay, now time has cost. If you go and you ask, I want to meet the CEO of a company, right? He's not going to give you his time for free, or he's going to ask why, right? At least you have to tell him a reason. So you'll realize this. Time is costly. Time has a cost. Acquiring knowledge has a cost. Okay. Physical things like computers, networks, these things have a cost. Now, sometimes these costs are monetary. Sometimes you can directly say, right, I want to buy a computer, it costs me so and so, $1,000, 2 lakh rupees, whatever. But sometimes these are much, much more expensive. Okay, the cost of acquiring something could be a lost opportunity. It could be your lost health. Okay, you work too hard, perhaps, don't sleep at night. You're going to pay the price. They say, no, you're going to pay the price at some point. So that's lost health and lost relationships also. Okay, if you're too busy with, let's say, work, you compromise on family. If you're too busy with family, and you might compromise on work, right? So every resource, everything has a cost. Nothing in the world comes free. And as the Americans want to say, there's no such thing as a free lunch. So learn to treat everything you get, okay, as a precious resource. Everything. The fact that you're sitting here, the fact that you're listening to a talk which may or may not make sense to you, okay, treat it as a resource. You need to, it's you who needs to extract something from this resource, okay? You have to use it wisely. This C-DAC ACTS course that you are going to join, that you are going to study in the next so many months, it is an extremely precious resource. I cannot state this enough. It is one of the most valuable resources you could ask for. How so? In terms of time, like Ashish and others said, you have access to computers, you have access to labs, okay, morning to evening, perhaps 24 hours in some cases. You have access. You have access to teachers, okay, you have access to professionals, right? You don't get this very easily in the industry. In the industry, everything comes at a cost. Here, you just have it, right? You need to make optimal use of it, right? You need to develop the right attitudes, the right qualities, and you need to take responsibility for yourself and others. Here I'll segue into the idea of responsibility. So I just said, take responsibility for yourself and others. What does responsibility mean? So as you grow in age, your growth in responsibilities kinds of mirrors your age, okay? When you're born and you're a baby, you're responsible for nothing. Your parents are responsible for feeding you, cleaning you up, giving you a bath. Literally everything is done for you. You have no responsibility at all. When you grow a little older, you're in school, you might be responsible perhaps for your siblings. You have to, take care of your younger sister or brother, or brothers or sisters. As you go in the school bus, your parents will tell you, take care of this child, make sure you keep an eye on her or him, right? You're given a little bit of responsibility. And you also have a little bit of responsibility for yourself, right? You have to study a little bit, get reasonable grades, whatever else your goals are. In college, when you grow older and you're in a hostel or something, you are almost totally responsible for yourself, okay, except perhaps financially, where your parents will send you money. In the beginning of a job, your responsibility has gone to where you are also financially responsible for yourself. Now, this is an outline. Everybody's story is different. And in family life, later on, when you're married and you have kids, you are responsible for yourself, your kids, your family, your extended family, your uncles and aunts and their kids, and so on and so forth, right? So as you grow in age, so does your growth of responsibilities happen, right? And then later on, what? Eventually, where does this end? So your sense of responsibility needs to expand, okay? And it expands till you consider yourself responsible for society at large. If you see a problem in society, it is not merely enough to complain about it. You need to offer a solution. You need to offer, or at least propose a solution, right? Like we've been speaking about problems here, that there's a gap between academia and industry, but we did not stop at complaining. We did not just lament the gap. We said we're going to solve this, right? So that is your scope of responsibility, and that is how it should grow. You should find issues and fix them. Okay, you should teach and you should spread the knowledge that you have learned throughout this exercise of your growing responsibility, right? You're taking responsibility that you should spread, you should give to others, so that society at large, the world at large, it grows, develops, and becomes a better place for everyone. and there is no reason to wait until you are older. Okay, you are there right now. You can take this responsibility. So this is what you must do, or what I expect someone in the industry, someone who wants good people to come out of educational institutions whom we can hire, whom we can give big responsibilities. You need to do the following. You need to increase your knowledge, okay, both in depth and breadth. You can't say, I know lots of things, but I know just a little bit of each, okay, like jack of trades, master of none, not okay. You can't say, I'm master of one and that's it, I know nothing else. Okay, that's pedantry, you should never do that. So you need to be good in many things. You need to have lots of things. So it's breadth, and you need to have deep knowledge in each of these things. All right. For that, you will be required to be in continuous learning mode, and the learning never stops. The 6 months is just not even the beginning. I have finished more than 30 years. I'm still learning. There are new protocols to learn every day. There's new stuff to learn every day. You need to develop excellent communication skills. Now, this is sorely lacking today. All right. This is bad, and especially given the fact that this is the social media world where you are used to communicating with emojis, right? I wish I could put a bunch of emojis on screen and smiley, 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 and done with my speech. I can't, right? So communication is extremely important, right? Your communication has to be precise and concise. It has to be exact and accurate. Not one word more, not one word less. Of course, these are ideals. Get there. You need to build a strong work ethic. Okay, so in terms of work ethic, first of all work is good. There is no such thing as bad work. Somebody tells you, go write this document. You shouldn't say, oh, I want to do design, I don't want to write a document. No, do not look down upon anything. Every bit of work is always good work. All right, everything is an opportunity for you to learn and grow. Okay, you need to develop a vivid imagination. Okay, a lot of the problems in the world are there could be surprising solutions to them, provided you imagined them in a different way, what you call reimagining things. So that isn't going to happen unless you have a very vivid imagination where you are willing to think independently in many, many different channels at the same time. Only then you come up with innovative and really true solutions that can work. Okay. You should patent every invention that you make. This is one of the mistakes that I made in my career. And it was a time when we did not even know the value of patents. Ashish will tell you that, and people who are from my generation, perhaps Parikshit, will tell you that. But today, when you make an invention, make sure that it is patented. Okay, make sure that there is clear line of credit, who made this invention and who should get credit as well as who should get the financial benefit out of that invention. Always publish your discoveries. If you discover something, it is not enough to just keep it in your mind or tell your colleagues. Publish it in journals. Okay, this is part of what we in industry need, right? And most important, share your knowledge. Knowledge is something which in Sanskrit they say, Vyaye krite vardhata eva nityam. The more you spend it, the more it grows. Knowledge is something that you must share. Only when you share with others, it's when your own knowledge also grows. So this is what we expect from you. Now, here is, like when we started with a table that showed the gap between academia and industry. Here we are pretty much at the end. So now I'll show you the gap between students and professionals. Okay. So for a student, failure is taboo. Oh, you failed in your exam, everybody will look down upon you. Shouldn't be, but it is. Okay. But for a professional, in professional life, failure is welcomed. I don't learn from success. Only when I turn on a new circuit and it explodes or burns up that I learn to debug it. There's nothing to learn from success, right? Your knowledge does not expand at all. You learned about how to design a circuit, you made a circuit, you turned it on, it worked. That's the end. You turned it on, it blew up in your face. Now you have the opportunity to learn a number of things. And what you learn is what errors are possible in that, how to improve upon that, right? So failure for a professional is a most welcome thing. It is nothing, not only something to not be ashamed of, it is something to be proud of. I have failed so many times. Okay, there are industry paradigms built upon this, saying fail early, fail often. You can look it up. Responsibility. For a student, it is only for yourself. I need to get so many marks, I need to do this, I need to get into a good college, I need to do this degree, so on. As a professional, your responsibility is for the world. Okay. The initiative. Okay. Initiative is you only do tasks that are given to you. Your professor will give you an assignment, right? And that's all you'll do. And your professor will grade you on it and so on and so forth. But a professional doesn't wait for somebody to tell me, go do this. I go find out what my company, what my industry, what my society, what it is lacking, and I go do it. Nobody tells me to do it. That is the attitude that we need to have. Resources. Students rarely understand the value of resources, which is why I spent a lot of time explaining to you about resources and how they're not free. Professionals understand the cost of everything in very minutely. We understand, we can even put monetary value to resources. We can say this person's, this much time is worth so many rupees or dollars, right? If at all you have to put that kind of value. But you have to understand minutely costs of everything. Objectives for a student are set by others. Others tell you what you need to do. Finish this, do that, go do this project. But the objectives for a professional are always set by one's own self. The scope of what you do, okay? Your scope as a student is limited to your syllabus, right? If you get a question that is not in syllabus, it causes an uproar. Arey, question out of syllabus, right? Will come in the newspapers and parents will be like, oh, they set a question that is out of syllabus. In real life, there is no such thing, right? The scope is literally everything under the sun is the scope, right? If your product is not working or it has a bug, nobody's going to ask you, are you the chip engineer or this? If you can find a solution to it, anybody can find a solution to it. Time, okay? In academia, as a student, other people are defining your time. You have to get up in the morning, go to school, do this, come back from school at this time, then go for a certain tuition class, which is the norm today, or do something. Others are defining timelines for you, but as a professional, you will define your own timelines, or you should define your own timelines, if not individually, at least collectively in a team. Speed. The speed that you might think, okay, you're doing, you're studying a lot in, for preparation for IIT JEE or I don't know, GATE or GRE or something, is nothing compared to the speed that a professional can work at. Okay, we know how to work insanely fast because we cut down all the unnecessary stuff and only focus on what is essential. Okay, perfection. This is a topic I have fights with people about. In academia and as a student, there is a definition of perfection for you. It is getting 100% in an exam. There is nothing better you can do anyway. But there is no such concept. There is no such definition of perfection for a professional. You build something that is extremely good, let's say an iPhone 15. Does that mean that you're going to stop there? No. You're going to go to iPhone 16. You're going to go to, I don't know, MacBook Pro Plus Max, whatever, right? Something that adds more honorifics to it. What is the greatest sin for a student? Plagiarism, copying, right? But the greatest sin for a professional is inefficiency. You should, whatever you do needs to give you maximum results in the shortest possible time and effort, least effort possible, right? Working hard is not a great thing for professionals. We don't like working hard. I don't like working hard. I want to work smart. In other words, if I put in 5 hours of effort, I want to see some tangible results coming out of that, right? Now, the second greatest sin for a student, it's pedantry, specialization in one thing, and again, being very specific, having specific knowledge about one thing which does not have much application or something like that. And for a professional, it is triviality. I don't want to do anything trivial. Unless and until it has value, it generates value, it is trivial. If it is trivial, I do not want to touch it. So this is how students differ from professionals. And finally, what do we want in the industry? What do I want for my students? I've been a teacher at C-DAC ACTS. What did I want from my students back then? I still teach occasionally. What do I want from my students now? And what do I want from students who come out from academia into industry? Hopefully you understand that now. you are here, your primary goal is to transform yourself from being a student to being a professional. Okay? Industry does not need students, industry needs professionals. C-DAC and ACTS, okay, we are here to enable this metamorphosis. All right. Whatever complaints are there, pedagogy is not right, methods of teaching are not right, these complaints ACTS tries its very best to address. It tries to fix these things. That's the reason why these courses are not 4 years, 5 years, 10 years long. They're 6 months, they're short. Okay. Teach right in the right way and get results in 6 months. That was like 30 years ago. These were our ideals with which we started. Okay, but this metamorphosis is not going to, cannot be forced upon anybody. It is you who has to do it, and you alone. Okay, now C-DAC ACTS, we give you the opportunity, you have the opportunity, you have already been accepted into this course, you have the resources, you have labs, computers, network, everything that you could ask for, teachers, and you also have proper pedagogy. The courses are designed with teaching you in the right way, because the goal was to bridge the industry academia gap, right? Now, everything is on you for the next 6 months. Okay, you need to learn what it takes to be a true professional. And you need to take responsibility for yourself, and you need to take responsibility perhaps for the broader society at large, for ACTS, for C-DAC. Okay, for if you see problems that this is not being taught right, you need to take the initiative and say this should be taught in this manner, or you should say I will teach it in this manner, right? And whatever you have, by the way, there is no such thing as sufficient resources. Okay, this thing is another truism that you will eventually realize. Like there is no such thing as sufficient money, right? If I give you 1 crore, you can buy a Porsche, right? Not with 1 crore, perhaps 3 crores, right? If I give you 10, you could buy something bigger. If I give you 100, you will find something new to buy. Similarly, there is no such thing as enough resources. Okay, if I give you 100 Gbps of network speed, you will find a way to exhaust that. You'll probably download 50 movies in parallel, right? The resources will always be scarce. That is never something you should complain about. The question is, whatever is there, are you utilizing it optimally? So you need to understand what optimal utilization of a resource means and utilize it optimally. Okay, good luck to everybody and make history. Thank you very much. I'm done. I don't know if there are questions, if anybody wants to ask something, perhaps, or if not, then if you're all very, very satisfied that yes, we know what to do now, go for it. Okay. No questions. Makes me very, very happy. Thank you very much. Okay, where should I go now?
Sorry. Thank you, sir.